Picture this. You are standing on a beautiful, sun-drenched beach. You watch the sunset just like any other Tuesday. But then, something feels wrong. The sun keeps sinking. It turns into a tiny pale dot. The warmth on your skin vanishes. The ocean stops waving. Within minutes, the water under your feet freezes with a sound like 1,000 windows shattering at once. The atmosphere literally collapses. Air turns into liquid, then into nitrogen snow. You aren't just cold. You are in a void. This isn't a scene from a Hollywood disaster movie. It is the birth certificate of the most common type of world. We call them rogue planets, cosmic orphans, worlds that were quite literally kicked out of their own homes. Right now, trillions of them are screaming through the void at 300 miles per second, and they aren't as dead. How does a planet lose its sun? And more importantly, how does it survive the eternal night? Let's step into the dark. You are watching Beyond Explained. Subscribe to explore the hidden mysteries of the cosmos with us now. Most of us grew up looking at posters of the solar system. Nice, neat circles. Everything in its place. Stable, right? Well, that is a lie. Early star systems are actually more like a mosh pit at a heavy metal concert. Pure chaos. Think of a young star system as a game of cosmic billiards. You have dozens of planet-sized balls flying around. Sometimes two giants like Jupiter come too close to each other. Their gravity grips like invisible claws. They pull. Usually the smaller planet loses. It gets whipped around and flung outwards so hard that it breaks the sun's leash. It achieves escape velocity. 1 second, you have a home. The next, you are an exile in the void. You are heading into the interstellar void, never to see a sunrise again. Is it rare? Not even close. We were wrong. Astronomers used to think these were astronomical accidents, but they are a feature, not a bug. They are everywhere. In 2021, a team using the European Southern Observatory found at least 70 new rogue planets in one single cluster. But wait, if you scale that up, there might be 20 rogue planets for every single star in the Milky Way. Think about that for a second. 20 to 1. Who is the exception now? Are we the lucky ones with a sun? Or are we just living in a very brightly lit, tiny minority? Okay, so you've been kicked out. Your sun is 1 billion miles away. You should be a frozen, dead rock, right? Not necessarily. Nature has a way of packing a survival kit. Let's look at 3 things that keep a rogue planet alive. First, there is the core. Deep down, planets are radioactive. Elements like uranium and thorium are constantly decaying, releasing heat like a slow-burning furnace. Second, there is the thermos effect. If a planet has a thick layer of ice, that ice becomes a world-class insulator. Think of a person in an igloo. Outside, it is -40. Inside, it's livable. The ice traps the energy. Third, we have the blanket of hydrogen. Many rogue planets take a thick atmosphere with them. This traps even more heat. Imagine a planet-sized thermos flask drifting through a freezer. The coffee inside stays hot. Have you ever wondered what it would be like to walk on a surface like that? It would be a landscape of pitch-black nitrogen glass. But if you could drill down through 5 miles of that ice, you wouldn't find more ice. You would find a liquid, saltwater ocean. It is a pressurized, dark, boiling world kept warm by the friction of its own gravity and its radioactive heart. Wait, liquid water? In the empty void? We were taught that water only stays liquid in the Goldilocks zone near a star. But the universe doesn't care about our textbooks. It creates its own zones. It creates Steppenwolf planets, named after the lonely wolf of the plains. They don't need a mother star to stay warm. They are independent. They are self-sustaining. They are dark, silent fortresses of energy. Now let's look into the heart of this mystery. If there is water, could there be someone else? Most of us think life is sunlight, photosynthesis, green leaves, morning rays. Without the sun, everything dies. But that is our earthly bias. On our own planet, there are places that have never seen daylight. Think of the deep-sea trenches of the Atlantic. There, 4 miles down, black smokers erupt from the crust. There is no light. The pressure could crush a tank. But life is boiling there. Giant tube worms, blind shrimp, strange bacteria. They don't need the sun. They eat the chemicals. They breathe the heat. Now apply that logic to a rogue planet. If there is liquid water and geothermal heat, there is a chance for life. A dark, alien biology we can't imagine. It could be a world of blind giants, a biosphere that has never seen a star. That makes you think, doesn't it? What if a rogue planet visited us? Not a collision, just a close flyby. It would be a nightmare and a miracle. Its gravity would tear at our oceans. Tides would rise like mountains. Volcanoes would wake up all across the globe. We would see a shadow passing through the sky, a visitor from the deep dark, but the odds are very low. However, some of these orphans find a new family. They drift until they are captured by the gravity of another star. The ice melts. The atmosphere warms up. The eternal night finally ends. They become regular planets again. It's a second chance, a resurrection. But most will just keep drifting, forever, out there in the great between. The Milky Way is more than just stars. It is a graveyard of lost worlds, and a cradle for hidden life. If you found this cosmic mystery fascinating, make sure to hit that like button right now. We are just starting to map the dark. Every rogue planet is a story of survival against impossible odds. Our newest telescopes, like James Webb, are looking for the heat signatures of these lonely wanderers. We see them in the infrared, small glows in the dark. Each one is a potential home for something alien. What would you do if you were born on a world like that? Would you even know that stars exist? Your sky would be a ceiling of thick clouds. No sun, no moon, no constellations. Just the internal glow of the ice. Life there wouldn't be looking up. It would be looking down, down into the warmth, down into the deep. It is a complete reversal of everything we know, a universe hidden in the shadows, and it is much bigger than ours. Space isn't empty, it is crowded. We just haven't turned on the lights yet, but we are getting closer every day. Wait, could one of these planets be heading towards us right now? Let's look at the data. Even if a planet came close, our technology would see it decades in advance. There is no immediate danger to Earth, but it reminds us how fragile our warm home truly is. We are just one kick away from the long night. If you want to see more mind-blowing space mysteries, check out our other videos and hit that subscribe button right now. Your support helps us explore the furthest reaches of the unknown. Thank you for watching Beyond Explained. Stay curious, explorers. See you in the next episode. Beyond Explained, always searching.